Thank you everyone for joining this session on redefining security for the cloud AI era. Today we'll walk through a little bit of how customers are adopting generative AI, some of the trends we're seeing in terms of how adoption is taking place and the different applications that are being built. We'll then walk through some of the security considerations that arise given these new types of applications that are being both used and deployed in production, and then break them down into sort of areas where we can add and improve security strategies going forward. My name is Samir. I'm a product manager at CrowdStrike, and I work with customers to build applications and security tools to help customers be more secure in the cloud. So let's get started in terms of walking through some adoption metrics that we've seen. Let's start off by just talking a little bit about the scale and speed in terms of how quickly customers have started adopting generative AI in their organizations. We've seen a 72% sort of adoption rate across organizations in terms of just using either ML or AI within their workloads or as sort of a companion sort of capability. Specifically, 65% of them use Gen AI functions, whether that's just in trial phase or using it again as sort of a productivity tool. The next bit is, of these 72% of customers, over 50% of them either feel that they're lacking or don't have awareness of some of the security policies that they require to be able to secure those applications. So security is a big consideration for them. And just given some of the customer experiences, the new and innovative apps you can build on top of these, as well as productivity gains, like I mentioned, the hockey stick curve that typically we've seen in sort of adoption is just getting started. We estimate somewhere between 250 and 300 billion in software spend over the next 2 years, just dedicated to building AI software. So given the various levels of adoption, let's talk a little bit about how these AI applications are actually built and the tech stack involved. It does look similar to other cloud native applications or other applications in terms of the layers involved. And this includes the 4 layers of the applications themselves, which, starting at the top, are the tools and interfaces that end users interact with and are powered by the foundational models themselves. The models are, of course, the large language models that are either pre-trained or fine-tuned on enormous amounts of data that's built to handle different tasks, whether that's text generation or anomaly detection or image generation. Now, to build these foundational models, of course, or to fine-tune them, it comes along with a large amount of data that's needed. And depending on sort of what the model is, it could be based off of publicly available data sets, proprietary or sensitive information, or domain-specific data as well. Now, at the base of the stack is the infrastructure, which provides the computational power and storage needed to develop, deploy, and run the models and applications. This, of course, includes cloud services like AWS, Azure, and GCP, or perhaps your own compute stacks, which typically have GPUs or TPUs for handling the massive computational requirements required by these LLMs. Now, given sort of how the application stack is built and the different ways in which models can be used, whether that's building your own model or using sort of a SaaS service, we need to consider the different levels of responsibility and the shifts that the responsibility a customer has to take on given the differences in consumption models. Now, as you'll see, we have 3 different sets of requirements in terms of the responsibility itself, split across the AI platform, application, and data in use. as well as three consumption models, whether it's building on your own, leveraging a platform as a service, or using sort of a SaaS or API based consumption means. Now, some of the things you have to consider based off the consumption model that I can share are when you build your own model, customers are fully responsible for collecting, curating, and securing the data sets used for training and inference. And of course, ensuring that any plugins that are used for the API connections and the application infrastructure is secure, including securing the endpoints, managing vulnerabilities, managing the infrastructure, as well as the entire deployment of the model itself. You might also want to consider things like the model's accuracy, the compliance, and any bias detection that might be involved. Now, when you move to sort of platform as a service, customers are then typically responsible for a smaller portion of it. Typically, the providers are responsible for securing the platform, and customers are responsible for things like the data they input into the platform, including training data sets or prompts, should they be either fine tuning or leveraging sort of the platform itself. The last is, of course, software as a service, where the security responsibility is really minimal, and the provider does deliver sort of a more ready to use sort of application with only a small portion of the security responsibility that goes to the customer. This is mainly around the data and its use and ensuring that appropriate access controls are involved. So choosing the right way of using and leveraging model is super critical. So customers can then align resources and expertise accordingly, so they can manage risks effectively. Why is this so crucial? Now, when things go wrong, it can go massively wrong. An example here is, of course, of in case of a sort of a low-code app builder where a vulnerability was discovered. This was specifically that the app itself had both cross-site scripting and CORS-based misconfiguration vulnerabilities that led to sort of an authentication bypass after exploitation. And once the specific exploit was sort of used by the researcher, they were able to pivot and move laterally to go figure out things like access tokens, API keys, and passwords that then allowed them to gain access to sensitive vector databases that contained, of course, sensitive information. Now, with that said, AI itself presents new security considerations outside of the typical application security considerations. Let's start with AI model safety. And when I'm talking about AI model safety, customers typically build AI systems with the intent to prioritize safety, ensure transparency, fairness, and robustness at every step and for every customer. This means models need to be free from unintended biases and withstand attacks that might be targeted to deviating from ethical and legal standards. This means there's a need for rigorous testing, monitoring, and adding guardrails, and perhaps other mitigation strategies as well. Now, when we're talking about data security, data, of course, is at the root of both training and sort of inferences when it comes to sort of things like RAG-based applications. So securing proprietary training data and ensuring data governance is crucial to sort of ensuring neither is sensitive information exposed, is trained on, or impacts things like privacy, which we can talk about next, where with models now being developed from scratch or fine-tuned and custom data, security teams and of course developers now need to consider how data is anonymized, secured, and minimize data exposure. As new regulations come in, things like the EU AI Act and adjacent ones like GDPR and CCPA, privacy concerns are not something to ignore anymore for in terms of security as well. And finally, all these applications run on the infrastructure, so it's crucial again to safeguard against potential threats and vulnerabilities for the infrastructure that these applications run on. Now that we talked a little bit about the stack, some of the options in terms of consumption models, and also discussed sort of the responsibilities and the shift in what customers might have to secure, let's walk through some risks to AI applications at a very high level. And this excludes things like what are the application specific risks itself. Examples of some of these risks include things like prompt injection and insecure input-output handling. This means you know malicious actors might be using crafted inputs to prompt for either sensitive data leakage or create sort of a sort of a pattern that creates an output that might be used to expose or influence other parts of the application as well. There's of course things like supply chain vulnerabilities, given that most of these applications are built based off of open source technologies, and then the use of things like insecure plugins as well. Now, given some of those risks, what's the appropriate mechanisms and security vectors we need to put in place to ensure that applications themselves are secure across their life cycle? Now, AI applications, of course, require a large set of security capabilities, but they're sort of in line with typical deployment patterns and security patterns you might have observed for building any cloud native application as well. Ensuring visibility, securing the data and supply chain, and monitoring application and behavior at runtime are things that allow you to create a framework and enables laying security at every stage of the life cycle of the app. Let's start with visibility because it's foundational. You can't protect what you can't see, which means many organizations who are adopting AI systems today without fully understanding the extent of their use, like what models are running, which data sets are involved, what tools are being leveraged, what third-party vulnerabilities or software is being used, can create a lack of clarity and lead to blind spots that attackers can exploit, or lead to inadvertent security issues when users themselves aren't aware of the risks involved. So building accurate inventories of AI resources provides transparency and allows teams to identify unauthorized usage and audit activity and ensure compliance. Next off is data security, which is a critical vector as AI systems often process and analyze vast amounts of sensitive information. Now, this poses a dual challenge because it's not just protecting the data used to train models, but also ensuring that the data does not inadvertently leak either sensitive data to unauthorized users. Now, AI supply chains are another critical area and one that flies under the radar typically, just given that most applications are built and rely heavily on third-party components. Whether it's open source AI models, pre-trained datasets, third-party libraries, or open source software packages, each of them introduces potential vulnerabilities that, if exploited, can compromise the entire system. Now, to counter this, customers must validate the integrity of all third-party AI resources, assess their sources, and implement safeguards to minimize risk, whether that's vulnerability management, whether that's data lineage, or whether that's just understanding which packages can be used in terms of building the applications themselves. Supply chain security isn't just about prevention, it's ensuring that you can trust and verify each of these packages at every stage. Finally, runtime security focuses on protecting AI systems when they're live in production, of course, and when they're most vulnerable to misuse or tampering or adversarial attacks. For instance, we spoke a little bit about prompt injection and input and output sort of manipulation. Malicious actors could, of course, use that to trick AI models into making incorrect inferences. So putting in place some sort of robust runtime defenses, including detection systems to monitor for anomalies and response mechanisms that can quickly contain and neutralize issues, is super critical to ensure the safety of the system. Now let's break down each of these into some deeper level risks and some strategies to secure them as well. Let's start with sort of how you can build effective security controls, with, of course, visibility being a crucial part of it. Now, to build effective controls, I think one aspect that most customers sort of leave out is putting in place sort of an effective governance culture. This means defining sort of an acceptable use policy. Where can customers or developers use these specific resources? And then build awareness about risks either through some sort of a training or continuous communication program. In terms of just building visibility, you spoke a little bit about building inventories that can understand what models are being used and packages and whatnot. But what it also means is going back and reviewing access policies, existing controls, and risk programs, because now they might have to be changed given some of the new sort of security considerations we spoke about, and prevent and these controls can then now prevent misuse or leakage of data via sort of unsanctioned AI deployments. Provide a safe alternative, validate and support approved AI tool usage, and start off with maybe a small set of users, learn from behavioral patterns in access patterns, and then potentially expand into allowing access to secure devices and then going from there. Now, moving on to sort of the data governance and security strategies. Securing data and creating a governance strategy is quite hard given a customer environment has data scattered across numerous systems. So there's opportunities to have many blind spots and several risks. Now, improving visibility into where your data is involves first and foremost finding where sensitive information lives. This requires customers to implement perhaps comprehensive data classification frameworks so that they can assess and label data based on sensitivity and importance. Secondly, establishing clear data ownership allows security teams to then assign responsibilities to individuals or application teams for specific datasets that they use and ensure accountability as well. Now, finally, gaining insights into how data moves across applications, whether that's within the organization itself or to external users, is vital for tracking both potential governance issues or to detect anomalies or unauthorized access. Now, specific to data, there's of course many regulatory and compliance standards that customers have to meet. What that means is also planning for and implementing sort of risk mitigation strategies in case of risks to those compliance sort of frameworks. And that starts with building out sort of a roles and responsibilities matrix in terms of who owns what, where does data live, and what actions to take in case of an incident. Now let's talk a little bit more about securing the AI supply chain, given that we've spoken about the visibility pieces as well as securing the data itself. Now, some of the best practices for securing the AI supply chain starts with ensuring that datasets themselves aren't poisoned. Now, there are no effective version control systems, for example, for handling datasets, which means the capability or the possibility of introducing false or biased data into training datasets is quite large. We spoke a little bit about supply chain vulnerabilities. Most of these are coming from third-party libraries and frameworks that are not necessarily part of the model itself, but are components that are used either for building sort of agent-based workloads or implementing sort of UI systems or interacting with different databases as data connections and whatnot. Now, finally, thinking about securing AI applications, especially when they're running, isn't just about protecting the technology. It is about safeguarding the trust that customers place in these systems to make critical decisions. So, when we're talking about securing AI infrastructure, it's essential to recognize that the runtime environment where models interact with real world inputs do present unique challenges. They are actively exploited in the wild, as we discussed earlier, but let's just focus for a second back on the risks. Uh, Now, when they're actively engaged with external inputs, some of these can certainly be malicious. A primary area, of course, involves input and output handling, and commands or unexpected data types can be introduced in those inputs that the model might not be equipped to sanitize, or the application itself. On the output side, though, improper handling of the responses generated by the model can expose sensitive data or result in unintended actions. So, for example, a model which was designed to generate code might inadvertently output exploitable snippets, and those that act directly on subsequent parts of the application can result in sort of unexpected incidents if it's not properly secured and verified. Now, weak authentication mechanisms or insufficient input validation in APIs can also open doors for attackers to compromise these APIs. And attackers often probe for these vulnerabilities and check for the ability to bypass authentication protocols or inject harmful queries and see if they can manipulate the system. And finally, for some of the more malicious actors who focus on sort of adversarial manipulation, attackers craft again subtle and deliberate inputs designed to influence the inference of the model itself and therefore make incorrect predictions or decisions or inferences. These risks do highlight some of the need for a proactive approach to securing AI systems at runtime. So real-time monitoring is critical and can mitigate attacks as they happen. And this includes, monitoring AI models and the infrastructure supporting them, such as the ones that we have in containerized environments. Now, by leveraging security tools, security teams can detect things like unusual activity, spikes in traffic, abnormal input patterns, and so on. Input validation is, of course, one of the simplest yet most effective defenses in many cases, and ensuring that any data entering the system conforms to what's actually expected, whether that's formats or other things. Now, the last and final bit is implementing sort of a red teaming approach. Proactive testing is invaluable. Red teaming does involve simulating attacks on your AI infrastructure to uncover weaknesses before attackers do. Now, this process not only identifies vulnerabilities but also helps refine how you would respond to incidents and builds a response strategy that ensures your team is prepared to handle real world threats. So, given that we spoke a lot about some of the security risks and challenges that customers have in terms of securing AI workloads, both the risks and the security strategies required to be able to secure them is a lot of onus to place on customers, especially in an area where there's often changes in a small amount of time. I want to wrap up by saying with CrowdStrike Falcon Cloud Security, you now have the ability to secure your AI workloads from pre-runtime to runtime, giving complete protection of AI workloads across the lifecycle of the application, whether that's assessing AI images and softwares for vulnerabilities, gaining visibility into the models that are deployed in cloud environments, or monitoring for runtime activity, given that some of these models run in containerized environments. With that, thank you for your time. I hope to see you all soon. And if you have any questions, feel free to post them. Thank you.